Hello everyone, and welcome back to the AI Academy, in today's session on Ethical Hacking series. We will be shifting our focus to the practical aspects of setting up a lab environment for ethical hacking. This is one of the most exciting steps in your ethical hacking journey because it marks the beginning of your hands-on experience. By the end of this session, you'll have a fully functional lab where you can safely practice penetration testing, simulate attacks, and learn how to identify and secure vulnerabilities. But before we dive into today's topic, let's quickly recap what we covered in our previous lecture. In our previous session, we explored the basics of routing from an ethical hacking perspective. Here's a quick summary of the key takeaways. We learned how data packets are delivered across networks using routing protocols. We explored the difference between direct delivery, host-to-host, and indirect delivery, via routers. Such as next-hop routing, focusing on the next destination along the path. Host-specific and network-specific routing, understanding how routing tables manage traffic for individual hosts or entire networks. Default routing, how routers handle packets when no specific route is defined. Routing plays a crucial role in network reconnaissance and exploitation. Understanding routing helps in simulating attacks like traffic redirection or analyzing packet flow for vulnerabilities. Building on that foundational knowledge, today we'll focus on setting up a practical lab environment. This includes installing the tools and systems needed for ethical hacking, such as a hypervisor, attacker systems, and victim machines. Configuring networks that allow these systems to communicate safely and securely. Ensuring everything is isolated to maintain a safe and legal practice environment. By the end of this lecture, you'll not only understand how to set up your lab but also be ready to start exploring ethical hacking tools and techniques hands-on. Let's get started. So, today, we're diving into the foundational step for any ethical hacker, creating a safe, controlled lab environment where you can practice and experiment without any risks. This setup is the heart of your learning journey, allowing you to simulate attacks, test defenses, and understand how systems work, all while staying ethical and legal. Here's an overview of what we'll dive into. You'll learn how to create a virtual lab on your computer, using tools that allow you to experiment freely and safely. Understanding hypervisors and virtual machine monitors. The hypervisors are the backbone of your lab. They let you run multiple operating systems, like Windows and Linux, on a single computer. We'll explore what they are, how they work, and why they're essential. Installation and configuration of attacker and victim machines. You'll set up an attacker machine. This is where you'll perform your ethical hacking activities. You'll also configure victim systems, which are intentionally vulnerable machines designed for testing. Network setup using VirtualBox. Finally, we'll configure a network within the virtual environment, enabling the attacker and victim machines to communicate. This allows you to simulate attacks in a controlled way. Let's talk about why this setup matters and why it's critical to your learning process. To provide a safe, controlled environment. Think of this lab as your personal ethical hacking playground. It's a space where you can make mistakes, try out tools, and learn without worrying about damaging real systems or breaking any laws. Everything stays isolated, your experiments won't interfere with your computer or the outside world. Emphasizes responsibility and ethics. Ethical hacking is not just about knowing how to exploit vulnerabilities, it's about doing it responsibly. This lab ensures that you operate within legal boundaries by practicing on systems you own or control. It's also a reminder that hacking should always be used for good, to identify and fix security flaws, not to cause harm. If you're serious about ethical hacking, this is where it all begins. Without a lab, you won't have a safe place to practice. You'll risk learning on live systems, which is both dangerous and illegal. You'll miss the hands-on experience that makes ethical hacking more than just theory. But with this setup, you'll gain the confidence to use hacking tools in a controlled, professional way. You'll understand how attacks work and how to defend against them. You'll be ready to tackle advanced techniques as you progress in your ethical hacking journey. Now that we've covered the what and why, it's time to get into the how. In the next sections, we'll start building your lab step by step, beginning with understanding the tools and systems you'll need. Let's get started, this is going to be fun. Laboratory environment for ethical hacking. Setting up a laboratory environment. Think of this as your ethical hacking sandbox, a controlled, safe space where you can explore, experiment, and learn without any real-world consequences. Disclaimer: stay legal and ethical. Let's start with an important disclaimer. Ethical hacking activities must only be conducted on authorized systems. You can't practice on systems or devices that you don't own or don't have explicit permission to use. Legal note: if you engage in hacking activities on external systems, whether they're connected to the internet or an intranet, you could face legal consequences. We are not responsible for any actions taken outside this controlled environment. Why is this so important? Because ethical hacking isn't just about skills, it's about responsibility. You're here to learn how to protect systems, not to harm them. By staying ethical, you build trust and credibility as a security professional. Now that you know why the lab is important, let's talk about the key components you'll need to set it up. These tools and systems will form the foundation of your ethical hacking environment. A hypervisor is the engine of your lab. It allows you to create and run virtual machines, VMs, on a single computer. These VMs will act as the attacker and victim systems. For example, VMware, a robust, feature-rich hypervisor, offers both free and paid versions. VirtualBox, a free, open-source alternative that is highly recommended for beginners. What it does: it allows you to run multiple operating systems on a single computer. Ensures complete isolation between the virtual environment and your actual machine, keeping everything safe. The attacker system is your ethical hacking toolkit. This is where you'll perform penetration testing, vulnerability scans, and exploit tests. Recommended options are: Kali Linux, the most popular operating system for penetration testing. It comes preloaded with hundreds of tools for tasks like scanning, exploitation, and forensics. Parrot Security OS, a lighter alternative to Kali Linux with added privacy tools. Backbox, focused on network analysis and security. So, why Kali Linux? It's beginner-friendly, widely used in the industry, and has a massive community for support. The victim systems are your targets for practice. These intentionally vulnerable machines let you simulate attacks and understand how to exploit and secure systems. For example, Metasploitable 2, a Linux-based VM with well-known vulnerabilities, perfect for beginners. Metasploitable 3, a Windows-based VM with a more complex setup and vulnerabilities. Older Windows systems, versions like Windows XP or Windows 7 are ideal for simulating outdated, insecure environments. By setting up these victim systems, you'll learn how to identify and exploit weaknesses in a safe, controlled manner. Alright, let's talk about the backbone of your ethical hacking lab, the hypervisor, also known as the virtual machine monitor. This is the software that makes it all possible, allowing you to run multiple operating systems on your computer simultaneously. If you've ever wanted to use Windows, Linux, and other operating systems all at once, the hypervisor is the best option. What is a hypervisor? A hypervisor is a piece of software that enables the creation and management of virtual machines, VMs, on a single physical computer, also called the host machine. Think of it as a bridge between your computer's hardware and the virtual environments you create. With a hypervisor, your computer's physical resources, CPU, memory, storage, and network interfaces, are shared across the virtual machines you set up, without them interfering with each other. The features of a hypervisor are like: it supports multiple guest operating systems. You can run different operating systems on the same machine. For example, use Kali Linux for penetration testing. Use Windows XP or Metasploitable 2 as victim systems. Each OS operates independently within its own VM. Resource sharing. The hypervisor allocates resources such as memory, distributes available RAM among VMs. Storage, lets you create virtual hard drives. Network interfaces, sets up virtual networks for communication between VMs. This sharing is efficient and ensures your host machine remains unaffected. Popular hypervisors. There are many hypervisors available, but let's focus on two of the most commonly used ones. First, we will discuss about VMware. Why to choose VMware? A robust and feature-rich platform. Great for professionals who need advanced capabilities. Versions. The VMware Workstation Player is free. VMware Workstation Pro paid, with more features. Who is it for? It is used by beginners and professionals alike. Next, we will discuss about VirtualBox. Why choose VirtualBox? It's free, open source, and easy to use. Supports Windows, Linux, and Mac OS hosts. Who is it for? Beginners, students, and anyone looking for a cost-effective solution. Since it's free and beginner-friendly, we'll use VirtualBox for this course. Let's get started with VirtualBox. Go to the official website, www.virtualbox.org. Download the latest version for your operating system, Windows, Linux, or Mac OS. The installation process steps are: Step 1. Run the installer. On Windows, double-click the .exe file. On Linux or Mac OS, follow the standard package installation process. Step 2. Follow the installation wizard. Accept the license agreement. Choose the installation location, default is fine. Allow VirtualBox to install the necessary drivers when prompted. Step 3. Complete the installation. Once the installation finishes, launch VirtualBox to confirm it's working. With VirtualBox installed, you're ready to start creating your virtual machines. In the next step, we'll set up our first VM, the attacker system. This will be your primary tool for ethical hacking. Now that we've set up the hypervisor, it's time to configure your attacker system. This is the system where all the action happens, your main platform for ethical hacking, penetration testing, and learning how to exploit and secure systems. Role of the attacker system. The attacker system is essentially your toolbox for ethical hacking. What does it do? This is where you'll run penetration testing tools, perform vulnerability assessments, and simulate attacks on the victim machines in your lab. It's designed to help you understand how hackers think and operate, so you can develop strategies to prevent and mitigate real-world threats. Why is it important? Without a dedicated attacker system, you wouldn't have the tools or environment needed to safely experiment with hacking techniques. Recommended operating systems. The attacker system runs on a specialized operating system designed for security professionals. Here are the top options. The Kali Linux. Why choose Kali Linux? It's a Debian-based Linux distribution specifically built for penetration testing and ethical hacking. Comes pre-installed with hundreds of tools for tasks like vulnerability scanning, network analysis, reverse engineering. Widely used in the cybersecurity industry, making it a great choice for learners and professionals. The main features are like tools like Metasploit, Nmap, Wireshark, Burp Suite, and aircracking are included by default. It is beginner-friendly, with an active community and extensive documentation. The alternative operating systems are like Parrot Security OS. Similar to Kali Linux but with a lighter interface and additional privacy tools. Includes features for digital forensics and anonymity, such as Tor and AnonSurf. Backbox. A Ubuntu-based Linux distribution focused on network analysis and security. Simpler than Kali Linux but still effective for penetration testing. For this lecture, we'll focus on Kali Linux since it's the most popular and beginner-friendly option. Let's get into the step-by-step process for setting up Kali Linux as your attacker system. Download Kali Linux ISO. Go to the official site, www.kali.org/get-kali/$kali-bear-metal. Choose the appropriate version, bare metal ISO, for your system's architecture, 64-bit or 32-bit. Create a new virtual machine in VirtualBox. Open VirtualBox and click on New. Give your VM a name, such as Kali Linux, and choose Linux as the type and Debian, 64-bit, as the version. Allocate resources. RAM, assign at least 2 GB, 4 GB or more recommended for smooth performance. Storage, create a virtual hard disk with at least 20 GB, 30 to 40 GB preferred for more tools. Attach the Kali Linux ISO. In the VM settings, go to Storage, add an optical drive to the IDE controller. Select the downloaded Kali Linux ISO file. Start the installation. Launch the VM and boot from the ISO file. Follow the guided installation process. Choose Graphical Install for an easier interface. Set up a username, password, and partition the disk. Guided partitioning is fine. Complete the installation. Once installed, the VM will reboot. You now have a fully functional Kali Linux attacker system. With Kali Linux up and running, you're ready to start exploring its tools and capabilities. In the next sections, we'll configure the victim systems to simulate vulnerable targets. Set up a virtual network to connect your attacker and victim systems. Get ready to put your new attacker system to work, it's going to be exciting. Victim systems. Now that your attacker system is ready, it's time to set up the victim systems. These are the targets you'll practice hacking on in your lab environment. Victim systems are intentionally vulnerable, making them perfect for safe experimentation and learning. Purpose of victim systems. Victim systems serve a crucial role in your ethical hacking lab. Simulated targets, these systems mimic real-world vulnerabilities, so you can practice exploiting weaknesses without harming actual systems. Hands-on learning, you'll understand how vulnerabilities work, how they're exploited, and most importantly, how to secure them. Realistic scenarios, they help you simulate real-world hacking situations, giving you practical skills that go beyond theory. Think of them as your training dummies in this controlled environment. Examples of victim systems. Here are some great options for victim machines that you can use in your lab. Metasploitable 2. A vulnerable Linux-based virtual machine specifically designed for testing and training. Features. Includes outdated software and services with known vulnerabilities. Work seamlessly with tools like Metasploit, Nmap, and Wireshark. Best 4. Beginners learning the basics of penetration testing. Metasploitable 3. A more advanced vulnerable system based on Windows Server 2008. Features. Contains vulnerabilities in both Windows and Linux environments. More realistic and complex than Metasploitable 2. Best 4. Intermediate to advanced learners who want to simulate modern attack scenarios. Older Windows systems, XP and 7. Older versions of Windows are great for practicing exploitation because they often have unpatched vulnerabilities. Features. Commonly found in legacy systems, making this practice useful for real-world scenarios. How to set up Metasploitable in VirtualBox. Let's go step by step to configure Metasploitable 2 as a victim machine in your lab. Download the Metasploitable 2 VM. Visit the official source, https://sourceforge.net/projects/metasploitable/. Download the .zip file containing the virtual machine. Extract the files. Extract the downloaded .zip file. Inside, you'll find the virtual disk image, .vmdk file, required for setup. Create a new virtual machine in VirtualBox. Open VirtualBox and click on New. Name your VM, such as Metasploitable 2, and select Linux as the type and Ubuntu, 64-bit, as the version. Allocate resources. RAM, assign at least 512 MB, 1 GB recommended for better performance. Storage, use the existing virtual disk, the .vmdk file, instead of creating a new one. Go to Storage in the VM settings. Add a hard disk and choose the extracted .vmdk file. Network configuration. In the VM settings, go to Network and select NAT or host-only adapter, if you want the VM to communicate only with your attacker machine. Start the VM. Boot up the Metasploitable 2 VM. You'll be greeted with a login prompt. Default username, msfadmin. Default password, msfadmin. Verify functionality. Ensure the VM is running and accessible. Use ifconfig to check the IP address and ensure it can communicate with the attacker machine. With your victim system now configured, you can set up additional VMs like Metasploitable 3 or older Windows systems for more diverse practice scenarios. Configure the network so your attacker system can interact with the victim machines. Start experimenting with tools like Nmap and Metasploit to identify and exploit vulnerabilities. This setup is your gateway to hands-on ethical hacking. Get ready to explore and learn. Network setup in VirtualBox. Now that we have both the attacker and victim systems ready, the next step is setting up the network configuration in VirtualBox. This is a critical part of your ethical hacking lab, as it determines how your virtual machines, VMs, interact with each other, the host system, and the Internet. Default network mode, network address translation. NAT is the default network mode in VirtualBox, and it's perfect for keeping things simple and safe while you practice. What does NAT do? It isolates the virtual machine from the host system and the external Internet. Each VM gets a private virtual IP address, provided by VirtualBox itself. This means your VM can connect to the Internet for updates or downloads, but external devices can't initiate communication with it. Why use NAT? Safety. Since the VM is isolated, any hacking tools or tests you run won't affect your host system. Ease of use. It works out of the box, with no additional configuration needed. Example use case. If you're using tools like Nmap to scan the victim machine, NAT ensures that the scanning traffic stays within the virtual environment. Advanced setup, Bridge Adapter mode. If you need more flexibility in connectivity, you can switch to Bridge Adapter mode. What does Bridge mode do? It allows the VM to communicate directly with your host system and the external network as if it were another physical device on the same network. The VM gets its own IP address from the network's DHCP server, making it accessible from other devices on the network. Why use Bridge mode? Communication. It enables seamless interaction between the host and VM, and between multiple VMs. Internet access. Perfect for simulations that require external connectivity, like testing web applications or downloading additional tools for the attacker system. Example use case. If you're simulating a real-world attack where both the attacker and victim systems need to communicate with each other and access external resources, Bridge mode is ideal. How to configure network modes in VirtualBox. Here's how to set up these modes for your VMs. Open VirtualBox settings. Select the VM you want to configure and click on Settings. Go to the Network tab. In the Settings window, navigate to the Network section. Choose NAT mode, default. Under Attached to, select NAT, this is usually the default. This mode requires no further setup. VirtualBox takes care of assigning private IPs. Switch to Bridge Adapter mode. Change Attached to from NAT to Bridged Adapter. Select the physical network adapter of your host system, such as Wi-Fi or Ethernet. Save the settings. Test the configuration. Start the VM and check its network connectivity. For NAT, test internet access by opening a browser in the VM. For bridge mode, use a command like ping command to test communication between the host and the VM. With this we come to the end of this lecture. Let's quickly go over what we learned today. This was an exciting step in your ethical hacking journey, as we focused on setting up a laboratory environment, your playground for practicing ethical hacking techniques. Here's what we covered. Why a lab is important. A safe, controlled, and legal space where you can practice without any risks. It's all about staying ethical and avoiding any unintended consequences while learning. What we did. Installed VirtualBox as our hypervisor to manage virtual machines. Set up an attacker system using Kali Linux, the go-to OS for penetration testing. Configured victim systems like Metasploitable 2 to simulate real-world vulnerabilities. Established network connectivity using NAT and host-only adapter modes, allowing the attacker and victim systems to communicate. Next time, we'll dive into the information gathering phase of ethical hacking, also known as reconnaissance. It's the first step hackers, and ethical hackers, take to learn about their targets. Here's a sneak peek of what we'll cover. Passive reconnaissance. Techniques to gather information without directly interacting with the target system. Tools like Hois, Netcraft, and search engine operators to uncover valuable data. Active reconnaissance. Methods that involve direct communication with the target, like DNS enumeration and network scanning. Tools such as Nmap, Nessus, and Metasploit for advanced analysis. Port scanning. Using Nmap to discover open ports, running services, and system details. Techniques like TCP Connect Scan, SYN Scan, and Stealth Scan to identify vulnerabilities. Advanced Nmap features. How to detect service versions, operating systems, and more using TCP/IP fingerprinting. Best practices and countermeasures to protect against reconnaissance. This is where we really start seeing the magic of ethical hacking, and I promise it's going to be super exciting. Before you go, if you found this lecture helpful, please make sure to like this video to show your support. Share it with friends or colleagues who are interested in ethical hacking. And most importantly, subscribe to the channel and hit that bell icon so you never miss a new session. Your support helps us create more awesome content and keep this journey going strong.